Hey guys, welcome to BreVITy, and today we're going to solve a very popular LeetCode problem called the threesome problem in Python. Now, if you want to understand the logic which goes behind solving this problem, I highly recommend you to check out the video which my friend Akash uploaded, which is down in the description. And in this video, I'm going to implement the same logic in Python language. So before we start solving the threesome problem, we can have a small recap of the twosome problem because the threesome problem is basically the twosome problem with just one extra step. So this is a twosome problem. We have an array of numbers and we have a target. We need to find any two numbers in the array so that they add up to the target. In this case, the number 7 and 11 add up to the value 18. So just like this, you may have an array of large number of numbers, can be anything. So we're going to solve it using a popular approach called the two-pointer approach. So the first thing you should do is to sort the array. So when solving the problem, you're going to see why we need to have the array sorted. In this case, the array is already sorted, so we don't have to sort it. And we declare two pointers, the pointer I and pointer j. So the pointer I will point at the first value in the array, and pointer j will point at the last value of the array. So it goes like this. The pointer I will point at the first value of the sorted array, which is 2, which is also the smallest value, and pointer j will point at the last value, which is 15. Now the current sum is 2 plus 15. Is 2 plus 15 equal to target? So what is target here? 18. Is 2 plus 15 equal to 18? No, it's not equal to 18. It's now we can check if it's greater than 18. Is it greater than 18? Is 17 greater than 18? No, it's not greater than 18. Is it less than 18? Yes, 17 is less than 18. So if 17 is less than 18, which means the sum is less than 18. So if sum is less than 18, we need to find a way to increase the sum in some way. So is it wise to increase I pointer or j pointer? If we can't increment j pointer because j pointer is already pointing at the maximum value. So in this case, we increment the I pointer. So if we increment the I pointer by 1, now it points to value 7. So the new sum becomes 7 plus 15, 22. So is 22 equal to 18? No, it's less than 18 in this case. Sorry, it's greater than 18 in this case. So if it's greater than 18, we need to find a way to reduce the sum. So if you want to reduce the sum, we can reduce the j pointer by 1. So if you reduce the j pointer by 1, it now points to 11, and the new sum becomes 7 plus 11, which is equal to 18. So the new sum is equal to the target. So you can return the value 7 and 11 or whatever the question requires. So this is a basic way to solve the twosome problem using two pointers.
So now I'm going to solve the twosome problem in Python. So there are actually many ways you can solve this problem, and one of the most popular ways is using hash maps. But in this case, we're going to go with two pointers because there are other variants of the same problem like threesome, threesome closest, which has to be done using two pointers. So learning two pointers will help you solve like every variant of the same problem like way easier. So first, let's read the question. We have an array of integer which is already sorted in ascending order. We have to find two numbers that add up to a target, and we have to return the indexes of both the numbers which add up to the target. And we can see example here 2, 7, 11 and 15, and as we see 2 and 7 add up to 9, so we have to return index 0 and 1. But in this case we are actually returning 1 and 2 because we have also specified that the index are not 0 based. So we assume all the index starts at 1. So 2 and 7, we assume 2 is index 1 and 7 is index 2. And the same thing goes for the other problem 2, 3, 4, and 2 and 4 add up to some number 6, and the index of 2 according to this question is 1 and index of 4 is 3. So let's solve this problem. So the first thing in the two-pointer problem in this case is we have to solve the elements, but the question they have already specified that the entire array is already sorted, so we can just move on to declaring two pointers. So the pointer I, which points to the 0th index, and the pointer j, which points to the last index. So length of nums minus 1 is the last index. So now we run a while loop. while I less than j. The reason we have this condition while I less than j is because I and j are basically pointed to different indexes, first and the last index. So every iteration, what we do is we increment I by 1 or decrement j by 1. So every time we increment I or decrement j, I and j coming more closer to each other. And if I and j meet, what we do is we are adding the same value again. So if I points at index 1 and j also points at index 1, we are basically, to find the current sum, we are finding sum of index 1 value plus index 1 value. Uh, and we check if it's equal to target, which you don't want because both the numbers should belong to different indexes. So we have this condition while I less than j. So first thing which we do in this loop is we have to check if the current sum, which is nums of I plus nums of j, is the current sum, is equal to target. So if it is equal to target already, it's good for us. We can just return the index. So index is basically just the pointer I and j, because I and j is the index of in the array. So it's I comma j. But since in this question they have specified it to be index starting at 1, we can just add 1 because all the index we are assuming it starts at 1. So if it's not equal, we have to check if the current sum, which is nums of I plus nums of j, less than the target. So if it's less than the target, the current sum is less than target. So we have to find a way to increase the sum in some way. So we are basically incrementing the I pointer by 1. Why we're incrementing I pointer is since the array is sorted, every time the index keeps increasing, even the value we assume it to be keep increasing because the array is sorted. So we are basically essentially trying some way to increase the sum to bring it close to target. So else case is if the current sum is greater than target. So in this case, we have to find a way to decrease the current sum to bring it closer to target. So we have to decrement j pointer by 1. So they have not specified any other edge cases here, so we can just run this problem. Yeah, so as you can see, the code runs, and this time complexity of this code is just O of n because in this question they've already sorted the elements for us, so it's just O of n complexity. It's a good method. So now we're going to solve a different variation of the same problem using 2 pointers. So now we're going to solve a variant of the threesome problem known as threesome closest. So first, let's read the question. We are given an array of numbers and an integer target. We need to find 3 integers in the array such that the sum is closest to the target, and we have to return the sum of the integers. So the thing which you have to notice in this problem is the term closest, because we have to find 3 numbers. The value doesn't even have to add up to the value target. It can be closest target. So if the target is some number like 10, and if any 3 numbers add up to 9, it can also be the answer because it's very close to the target. So if you look at an example, you can understand. We have a array -1, 2, 1, and -4, and a target 1. So in this case, the numbers -1, 2, and 1 add up to the sum 2. So 2 is the closest you can get to target 1 in this case. So we basically return the sum. So now we're going to solve this problem. So to solve a threesome problem, what we're going to do is copy the 2 pointer logic used in the twosome problem to the threesome problem. The reason is threesome problem is basically just the twosome problem with just one extra step. The one extra step is having the second loop. So why do we have the second loop? So the twosome problem, as the 2 pointer technique which we use here, we are essentially finding the sum of I pointer plus j pointer. And since this is threesome, we are running a loop for the third pointer. We can call it the pointer k, and we can run the 2 pointer algorithm on the right side of the pointer k. So to find a sum of 3 numbers is basically just the sum of the value pointer k is pointing to plus pointer I is pointing to plus pointer j is pointing to. So we can run a loop for the pointer k for k in range length of nums -2. So why do we have -2 is to have the 2.2 some portion to work, we need to have at least an array of size 2. So giving an extra space for the two sum problem to work. So I can just change this. So the two sum logic is basically applied to the right portion of the case pointer. So to make it seem to be in the right portion of the k pointer, the I value should be k plus 1, and the j value can be, as usual, length of nums minus 1. So since in the previous question the given array was already sorted, in this question it's not sorted, so we can just use a inbuilt sort function to sort this. So the small change here we're going to do is have nums of I plus nums of j plus nums of k, because this is a three sum problem, so we need to have three integers. So to make it easier, I can just declare a variable which with nums of I plus nums of j plus nums of k, and I can just replace this with current sum. So this is a current sum. So if the current sum is equal to target, in this, according to this question, they want us to return the sum itself. So we can just return current sum. If it's the current sum is less than the target, we can we have to find a way to increase the target in some way. So we are increasing the I pointer. If it's greater than target, we need to find a way to decrease the current sum in some way. So we are decreasing the j pointer. So, and one thing in this question is this variant of the three sum problem, they want to find the sum which is closest to the target. So it need not be equal to target. It can also be closest to target. So to implement that, we can use a variable called difference, and we can initialize with infinity. So you'll understand why we are doing this in a second. So to find the difference between the current sum and target. So the target can be a value 10, and sum of three integer can be having a value 9, which is very close to the target. So we need to try to minimize the difference between the current sum and target in some way. That is, we're trying to make the difference as close to 0 as possible. So the difference is basically current sum minus target. So if current sum minus target is less than the difference we had before, which have initialized it to infinity, because if we initialize with 0, it's already the lowest possible difference, which we don't want. So we're initializing it with infinity. So if the new difference is less than the current difference, we can just modify the difference to be the absolute difference between current sum and target. So every time this if loops iterate and the difference gets lower, it means we're finding another sum which is very close to target as possible. So to find the sum which is very close to target, we can just use a variable which is new sum equal to current sum. So if the loop breaks and if current sum is never equal to target, we are basically finding a sum which is very close to target. So in which case the program will essentially break from the loop, and we can just return the new sum, and we can just run this code. As you can see, the program is quite fast, and the complexity of this code is like first we actually sort the array, so it takes n log in complexity as the worst case, and then the two pointer will take O of n complexity, and we are actually using the third pointer k, which takes another O of n, so it makes it O of n into n, so it makes it n square complexity. So any variant of the same problem we can just understand by, if you understand this portion, which is just the two pointer portion, and to solve other variants you can just basically add an extra loop and do some modification to the if conditions till you can get the results. So thank you for watching, and try out other variants of the problem.